Welcome to the project demonstration of microgrid formation and real-time scheduling of active distribution networks. So the main application of this project is whenever the power fluctuation occurred. So generally, as we know that UPS is nothing but uninterrupted power supply. Whenever the input power supply from the grid disconnected, then the UPS will be connected. But now in our project, the system will continuously monitor the fluctuations. The main fluctuations due to voltage or frequency means whenever the grid is providing power supply from the distribution transformer, if any fluctuations occurred with respect of voltage dropping or increasing the voltage or frequency dropping or increasing the frequency, whenever these fluctuations are occurred, then the system will disconnect the power supply to the load and it will connect the main microgrid power supply system to this load in order to provide the uninterrupted power supplies for scheduling the system. So like in this way we are going to providing the active distribution between the networks. So one is the grid we are using, and we have made this system for representing as the microgrid. So the microgrid purpose we are using DC network or DC battery source which is rechargeable battery, so which is the rating of 12 volts 3 amp battery pack. So as you can see this, there 3 batteries are connected in series, so we will get 12 volt 1 amp 1.5 ampere rating from the battery pack. Each battery is a 4 volt 1 amp 1.5 ampere. So parallelly we are getting 12 volt 1.5 ampere battery output load, and that is the input to the grid system, the microgrid we are using, which is used to convert the 12 volts DC to 12 volts of AC in the first stage. The next stage is the 12 volts AC will be step up to the 230 volts of AC, and that is input source to the load whenever the fluctuations occurred in the main grid section. So the main components are we are using voltage and frequency changing purpose. We are using the 2 potentiometers and 16:2 LCD screen continuously monitoring the status of this voltage and current, and status will be displayed. And we are using PIC microcontroller for monitoring of these fluctuations. So we have interface the A0 and A1 for these inputs for fluctuations making purpose, and LCD at pin number B2 to B7, C6, C7 for the relays for switching purpose in order to provide the uninterrupted power supply whenever the fluctuations occurred, and buzzer at the C4. And this one is a charging circuit which is getting power supply from this transformer as well as to the load. We are distributing that to the battery for charging purpose. And this one is the inverter board to convert the 12 volts of DC to 12 volts of 230 volts of AC directly. Just on the power supply to this, and a welcome message will be displayed on the LCD screen, and the status will be displayed like voltage 234 which is getting from this, and we can change that with the help of this potentiometer and the 50 hertz of frequency. So the limits for the voltage is 220 below, 245 above is abnormal, and 4950 is normal, and when it is less than 49 or above 50, then it is abnormal. So let us see that. So I am increasing the frequency now, right? So when the frequency increased, then high frequency will be displayed on the LCD, and the buzzer will get switched on to provide the audible alert. So this is the on off switch for the inverter purpose, right? So let us see again the reset switch. Right. So it is normal. So just on this one initially, and now so if it's an abnormal occurs, I mean increasing the frequency, so you can say there is no like delay to connecting between these grids, microgrid and normal grid. And when it is normal again, till you can see the message on the LCD screen, right? And it's normal again. Okay, so you can see low frequency, relay, and high frequency, normal. And same for the voltage also. So I am increasing the voltage, high voltage, normal. So you get 230H. So I am decreasing the voltage when it is below the 220, right, low voltage, right. So in this manner, the load will be getting continuous power supply when the fluctuations occur in the grid. So by making the microgrid, we have achieved this distribution system without any interrupts. Thank you.